Hi everyone. Based on some feedback from some of the groups in class, I'm going to make a slightly longer video on how to download and install R and RStudio so that you can do the different types of analyses that you're working with. And to start off, you'll notice that there's a couple of lines that are added to the R script. So if you were noticing some issues with installing specific packages, it's likely because two packages that I thought were default options ended up not being default options. And installing those packages will allow other packages to be installed more easily. And they are DevTools and Shiny. But in order for us to get there, we have to first download R and RStudio. So what we'll do is go through the process of downloading R and then go through the process of downloading RStudio and then going through what you would have to do for the second part of the lab for R and SPSS part 2. So if we go through our assignment here, what we would see is the first thing we have to do is to download R. And then the second thing that we have to do is to download RStudio. So starting with R, I would click on the button that says CRAN on the top left, and then I would pick which server is best for my download. I'll click on the cloud.r project and that will take me to the closest server that I'm working with. If I have Windows, I will click on the option that says download R for Windows. If I have Mac, I would click on the option that I have for Mac. So I have Windows, I would click on Base, and then I would click on the button that has download R for Windows here. I'll save the file, and notice I'm saving the file to my downloads option. I am not saving it to the desktop. As a general rule, you do not want to save information to the desktop when you're downloading files for the first time, especially files that you're using to install information. So I would hit save. It already has this version because I installed it previously, so I'd say yes, let me replace it. And then R is downloaded. And if I needed to install R, I would double click here or on your downloads option, and it would open the installer for R for Windows or for Mac. The next thing that I do is I go to RStudio and I download RStudio, and it does the same thing. So it opens up RStudio. I scroll down to RStudio Desktop, and I click on the Open Source Edition. I hit the Download RStudio Desktop option, and I make sure I click on the one that says Free. Most of what you would need to do for this class or any other class can be done using the free version of RStudio. So I hit download, I hit the button that auto-pops or auto-populates my version of RStudio based on the browser that I'm working with. I hit save file. I already downloaded this file already, so when it says do I want to replace it, I would say yes. It will likely have that version for you if you already downloaded RStudio. If not, then just hit OK. And again, make sure you save it somewhere that is not the desktop. And I just wait for it to download, and it's downloaded. Once I do that, I would then install RStudio after I install R. And once it's installed, you would have something that would look like this. So that has the work that we did earlier today. If I wanted to restart R, it would show up with this information here. So it says which version of R I'm working with. It's version 4.0.3. It says that R is a free software and that it's collaborative. And then everything that is in this white font here is what I would be working with. There are ways that you can personalize the colors if you want to personalize it. I am using a color scheme that I created myself. You can have the colors be whatever you want them to be. Once you see this screen, this is part 1 of the lab, or the first aspect of the lab that you have to do for this assignment. The next thing that I would do is I would click on the button here to download my file for my R working directory. I would hit save, and I would save this in a new folder in my documents. So I would go to my documents, and then I would find a new folder. We'll say Psych210 files. And once I do that, I hit save, and the file is there. I'll go back to the assignment, and I'll click on the data file, and I will do the same thing. So I go to File, Save. Note that the file is a CSV, or a comma-separated values file. And what you would want to do is to make sure that your file is saved as a CSV in the same folder that you saved your R script in. Again, Documents, Psych210 files, and then the file name here is R data Psych210 number 1. Both of those files have saved. And now what I do is I open, or actually before I open the file, I would go to Global Options. And when I'm working with Global Options, I just want to make sure that when I'm not in a project, that the option is set to have what's called my working directory, or where R saves all of its material. I want that to be in the folder where my R script is saved. So in this case, I'm going to hit cancel because I don't want to change how R works in my personal laptop. However, you would hit OK in order to maintain these changes. Once that's there, I go to File, Open File, and instead of where I have my working files at to start, I would go to my Documents, Psych210 files, RStudio Demo 1. Now, if you're more familiar with computers, or if you like coding or language processing with computers, or if you want to have more customizability, then you can save your files in any folder that you want them to be in. The problem is that if you save it on the desktop, then R does not like it to be saved on the desktop, and you should find a place to save it alternately. And if you save it just in the downloads folder, then once your download folder gets cleared out, then all of your data will also go away. So it's a best practice with managing data to have its own folder, and to have that folder nested somewhere that is important. That especially matters because once we get to loading data, what then becomes important is where is all of the information that we're working with that includes the different analyses we would do in R. What you saw is I uploaded my R script from where I saved it, RStudio Demo 1. Once I did that, the next thing I'm going to do is to install these two packages here. Now note that on line 12, 13, and 14, it says, if you are installing packages for the first time, run these sections, or what R calls chunks. You would first install DevTools and Shiny. And the way you do that is you take a backspace so that the comment goes away and it treats it as code. And then you hit the play button so that it installs it as its current chunk. So I'll do that here. And what we can see on the bottom is it is downloading information to run the latest version of both packages. It just downloaded DevTools. Now it's downloading Shiny. And now it's downloaded Shiny as well. Once I do that, I put the hashtag back in front of it so that it's returned to as a comment. I X out here because I don't need to see those warning messages. And I now do the same thing for these four packages here. The psych package, the tidyr package, the dplyr package, and Jamovi, which is spelled JMV. Do I want to start R before installing? Yes, I do. So now it's just saying, let me reinstall R or restart R so that I can redo analyses. And as we notice, on the bottom here, it's installing packages again. And what this allows me to do is to make sure that I have the most up-to-date packages that I can work with. Now, you'll notice that a new dialog box pops up. Some of you might have seen this as text before, but now it's a dialog box. And the reason that it's a dialog box is because I installed DevTools and Shiny. When I see a package that says, or an option that says, do I want to install from sources the packages which need compilation? The answer is yes. Because what that means is instead of using binary language to install packages, it allows more information to be used to install the packages that I'm working with. And so again, you're seeing a bunch of information run here. What this is basically doing is it's saying, let's run dplyr so that it installs and then builds the package as we need it to be built. We just wait for it to finish, and it's finished. Well, dplyr is finished. Now it's waiting for Jamovi, and Jamovi is now finished. So we have all of these packages installed. Now I take the hashtags and put them back so that they're now comments again. I then go to load my packages that I just installed. I see this message here that's basically saying that some commands from some packages were overridden or masked from other packages. That is totally normal. I X out there. And then I get to where I import my data. Now, what you will note is that this is what I had when I originally did my data set. And it was saved in a folder for where I set up all of my teaching. However, what you all would have to do is install or upload the data from where you saved it in your folder for Psych 210. And the way that that works is you would go to Browse, you would go to the folder under My Documents that has your data file, and you would click on it. And notice that the rest of the script has everything auto set up to JeffDat. And the reason for that is because what you would do is you would load the data in, and then you would just run all of the code automatically afterwards. So you don't have to change anything once you load the data in. So how does that work? I don't like to see my data after it's uploaded, so I uncheck the button that says Open Data Viewer. I then copy what I have for my code in terms of how to upload my data file. I hit Import. And on line 40 now, I hit Control V for paste. And just to make sure that it works, I hit the play button or the run button. I see this notice that says that this link does not exist. However, tilde, which is a shift and the button next to the number 1 sign, and then backslash, means in my working directory, where is this file? Or in my hard drive, where is this file? Tilde backslash tells me that is where I'm looking for. And once I do that, I then see this info. I see how R uploaded my data, whether it is a double coded or a character coding. I see the name of my variables, and I see the dimensions. I have 150 people that I collected data from, and I collected 4 variables and an identifier for each participant. Once I do that, that takes care of step 2 of opening my R Markdown file from class, opening my data file from class, having it in the same folder. And note that it's a folder, not the desktop and not the downloads folder. And then I just run the information as needed from there. And in fact, what you'll see is instead of place a hashtag in front of lines 17, 18, and 19, instead it is in front of lines 17, 18, 22, 23, 24, and 25. So it's running the first 2 chunks to install the packages. Then import your data. And then running lines 41 to 42 to make sure that your data works correctly. Once we do that, we go to step 3. And step 3 is just describing our data. I hit run, and because my data is named JeffDat, all I have to do is to hit the describe button, and I click on the data frame, and I get all of my descriptive statistics for class rank, favorite candy, likes music, and the textbook. As we already established, favorite candy is a nominal value, so those numbers have no meaning. But class rank has order because it's an ordinal variable, so the median does matter in that case. And likes music or likes textbook and the music are on an interval and ratio variable. And I can get the mean, the standard deviation, and the median for those variables. I also see the minimum and the maximum values that exist, as well as other variables we'll talk about as we get through the second month of the class. This second row on row 48 is a table, and that table is what I use to get the mode. So in this case, the category that occurs the most is Kit Kats. So folks who like Kit Kats are in the category that is the mode. Or when I say what is the mode for this data set, it's Kit Kats. Now, what I can also do is look at data in specific groups. And I can do that whether it's how much they listen to, or how do the groups of people who have different favorite candies, how do they differ in terms of listening to music, how do they differ in terms of how they rate the textbook, and what is their median rank in terms of students. So I could run them all at the same time and I would get 3 different outcomes, or what they call tibbles. First tibble is how much they listen to music. The second one is how do they like the textbook. And the last one is the median rank. What I could also do if I want to see just one of those values at the same time is just run the code that says for average time listening to music, just highlight those rows and see what happens. And now I just get one updated tibble, and that update tells me just for music what's happening. Then I can do the same thing for how much they like the textbook. And then I could do the same thing for the median rank student in that group. Once I do that, I'm done with step 3. And once step 3 is done, the only thing that is left is step 4. And with step 4, it's writing up our results of what we did in 2 to 3 paragraphs. So what did you investigate? Basically that says, well, what were the variables that you looked for in this study? Or what was the goal of doing this research? And then also in that paragraph is, how do you describe the statistics or descriptive statistics of your overall sample? So after you collected and analyzed your data, well, how would you describe the typical student that was measured in this data set? Then in paragraph 2, you would say, well, if we looked at each group, and each group is the student's favorite types of candy, well, how does each group differ? And so I would start with describing each group's descriptive statistics. So for people who like Kit Kats, how much did they read or like the textbook? How much did they listen to music in a day on average? And what was the median rank? And then I would end that paragraph with, well, what differences do I notice? Were there differences in how much they like the textbook? Were there differences in how much music they listened to every day? Were there differences in what the median ranked student was? And then when I'm doing these results and when I'm writing up my results, I would make sure to include relevant descriptive statistics. So what's the overall sample size and the sample size of favorite candy by group? AKA how many people liked Kit Kats, how many people liked M&Ms, how many people liked Skittles, and how many people liked Starburst jelly beans. And then, depending on what type of scale my variable is, well, what's the mean? And what is the standard deviation if I report the mean? Or what is the median? Or what is the median? Or what is the standard deviation if I report the mean? Or what is the median? Or what is the mode as relevant. So once I do that, I then do two final things. The first thing I do is I hit the save button to save my work, and I hit the knit button so that my results would be saved as a Word document. As you can see, most of that works here. My apologies for the interruption there. I forgot that if you install a DevTools and Shiny package, it will often have an issue where you will be writing a new file onto the hard drive created from another program. And depending on the antivirus that you have, you might get an error message that says, why is R trying to create a Word document? So if you see that error message from your antivirus, hit allow so that RStudio can create files, and then you'll hit knit. Once you hit knit, then the file shows up automatically, and now you have all of your output that you need to do your statistical interpretations. So the last thing that I would do is to go to File, Save As, and note that it's in the same folder that you saved everything else as. And I'll rename it R Demo or R Lab, or no, Lab 1 R Demo dash output. You'll see this dialog box that says it upgraded to the new version of Word. And then I upload this as one of my two files that I upload. Again, for the RStudio assignment, you are uploading two files for a complete lab. File number one is the output, either in a doc or a PDF file. And then the second file is a doc or PDF file or a text entry where you enter all of your information to answer the two paragraphs that you wrote at step 4. And as a reminder, those paragraphs should not be longer than 2 pages. And for many of us, about 1 double-spaced page should be enough to complete both paragraphs. And with that, that is our demo for Chapter 1. Or chapters 1 through 4 in Lab 1.